C'est au rez-de-chaussée. Le bar est en face de la réception locale, c'est ça? C'est très bien. C'est ça, c'est un stade. Donc c'est là où il était le groupe poste. Cool. Tout à l'heure.
C'est chaud, c'est chaud.
Okay, this is the room for the LP1 working group. If you're coming from MPLS over Saber Lasers, then you're in the wrong room. Okay, well, this would be starting. Oh yes, it's time to be started. So do you want me to do the intro?
So yes, hello everyone. Welcome to the LP1 working group. This is the note well. You should have read it, and if you have not, please do read it. So you have all the nice things that are there about so this is an IETF participation, and everything that you say here, it is going to be considered an IETF contribution. And what is all the IETF contributions? You know, if you're aware of any IPR that is owned by you, your sponsor, you'll need to disclose this to the chairs. So please do read if you have not done so, the different BCPs that are here. Yes, and as a reminder, of course, minutes are taken, and the meeting is recorded and streamed live on the internet, and the presence is logged. Please do not forget to write the blue sheets, to write your name on the blue sheets. So you have the minutes are taken on the Etherpad. So we have the Etherpad link that is here on this on the presentation on the materials. So you can find it through the website of the IETF. If you go to the agenda and meeting materials, you can find this one there. Yeah, please do contribute to the minutes. Yes, so we have a couple of our traditional minute takers that have already said that they will take minutes, but we would like, some of them are presenting. So who else would like to help take minutes? Fabrice, thank you very much. And Ivo also is going to be taking. Thank you very much, Fabrice and Ivo. So we really encourage people to use the Meet Echo, but we also may need a JavaScript. So is there anyone that could do the JavaScribing? Okay, thank you very much, Eric. Eric is going to be doing the JavaScribing. And yes, all the meeting materials are on the data tracker, all slides, all things are there. So my dear co-chair Pascal has this very good way of showing how to go and get these things. So we'll see this later. For our agenda for today, we have a very tight agenda actually. So we have a lot of items, so we start with. So the agenda is here. It was published. We have the main topic, or one of the main topics that we had until now, which is the SHIC header compression, and then we have Sigfox LoRaWAN and other different technology drafts. And one really important point is that we, at the end of the time, we have -5 minutes, so we're probably not going to be having a lot of discussions yet. So, do you have any modifications, any agenda bashing at that time? No, so we just continue with our general overview. What happened in the past year or so. So we finished our charter item number 1. On charter item number 2, we did finish and we submitted the draft for publication. So we are really well advanced, and right now we are also in rechartering, and we'll be talking more about this at the end of this slot. So if you want to see an overview of what has been happening since our creation, we have been very active. A lot of so regular hackathons with regular results, and Dominique is going to be telling us more about this thing. We had again 6 interim meetings since our last IETF, so really a very good pace. And if you would like to participate, it's really open. Please do join. A lot of work is happening over there. So this is, of course, the good point that we had working with Pascal that finished with success. So that's really congratulations and to the whole team, and congratulations to everyone that really put a lot of heart into doing this, and thanks a lot to every one of the reviewers that did a lot of very serious work there. So I think that's all from me, pretty much it, and we can get down to business with the first presentation from Dominique.
Hello everyone, good afternoon. So I'm going to talk about the SHIC. Yeah, well, if I want to point to anyway, I'm going to talk about the SHIC draft, the static header compression and fragmentation draft. First, just remind everybody what this is about, just in case you joined the group recently. Then I will go through what has happened since the last meeting in Bangkok, and tell us a little bit of what we did this weekend at the hackathon and what's coming in the next few weeks and months. So this draft is three things in one. It's a specification of a generic header compression engine. It's a specification of a fragmentation protocol, and it's a specification of how you apply the compression to UDP IPv6. So it's really 3 topics that are related, but that could potentially have gone into separate documents. But for some reason, we deliver them all 3 in the same document. So basically, the header compression was mostly reworked, rewritten first half of 2018. The fragmentation protocol and the description was mostly reworked and rewritten second half of 2018. And the UDP application of the compression engine to UDP IPv6 is from earlier times. So what did we do recently? After Bangkok, we initiated a second working group Glasgow that was especially focused on fragmentation, because that was the new part. It was closed end of November. And we also had a presentation of that fragmentation to the LoRa Alliance that was curious about what the new fragmentation mode was. And they were interested in reusing that for some of their internal works. And I think we're going to have a presentation later on about that. One of the decisions that we made during the fall was to make the fragmentation MIC optional again. This had been a long-going discussion. So the text as it is now says integrity checking is mandatory when you do fragmentation, and MIC is one way of doing it. But if you have a known better way of doing it, then you don't have to have a MIC field. This was a strong request by some of the contributors. As a result, ticket number 32, which captured that question already a couple of years ago, has been updated with the recent discussion and decision. So we can point IESG at that text to understand why we decided that and why we think it's safe, because that's a critical issue. Then we reworked the text this fall based on Charlie's review. Thank you very much, Charlie, for all the time you invested into making our text better. So we really owe you a big thank you for that. There was one issue that Charlie raised, which was the interoperability and the description of the rules and the details of the rules. And we decided, knowingly, that it will stay rather vague in this document because we have another draft coming and Laura is going to talk about it. That will describe that precisely. So eventually we published revision -18 and submitted to IESG for publication as a standard track RFC in December 15th. And since then we recently got an early review by Carsten, which is only a partial review as the IoT Directorate. And we have already worked on that. And then we had this hackathon last weekend, and so there were 9 team members. Some of them, not exactly all, are on the picture. We had 2 remote attendees, one from France, one from Japan, working on a night shift at local time, and 3 new attendees to any form of IETF event or hackathon. We worked on the open source implementation of Check. The URL is shown on the slide. And what we did during this weekend was twofold. One was making the code easier to use, easier for a newcomer to understand, to grasp what the code is, what it does, how to run it. So we produced documentation, we added tests, etc. And on the other hand, we also improved functionalities. We added compression features, added tests, and added connection to real hardware to be able to test over a LoRaWAN live network. What we discovered at the hackathon is some implementers did not quite understand fully the draft. So as a result, we'll add examples in the appendix section as we republish the draft following the directorate's reviews. And the implementation is also a good source of information for this new draft that's coming up that describes what is in the context, what describes the rules. And so implementers told us, I need to know this, I need to know that. So it serves as a reminder that it must be in the new draft. And what's coming up next? Take action following Carsten's comments, and we'll probably publish a respin of the document shortly, and then expect the other reviews from IESG. And also in parallel work on the OpenShift open source implementation. That's it for me. Questions?
Hi, I'm Charlie Perkins from FutureWay. I didn't see Carson's comments on the LPWAN list. Did I just miss it, or?
Yeah, you probably missed them. It was an attachment, a text file. Carsten actually took the text version of the draft and added comments in line. So look, I think it was March 4th. Look at one of his emails. I think it was on the main LP1. I'll double check. If not, I'll send them to you specifically.
Okay, I looked just then. I didn't see it, but okay.
But yeah, because it was an attachment, it could be easily missed. The mail was very small and the file was attached.
Okay, thank you.
And it was earlier review anyway. It didn't pretend to be the review. It was, here's my first comments if you want to do some prep work on that.
Carlos Gomez, on this point, it seems like the email was not CCing the mailing list of this working group.
Oh, it was not
so
on
it was
the
one
group.
of the email expansions of the authors of the document.
Oh, okay. So I stand corrected. It was not sent to the mailing list. But we'll send them to you anyway.
Thank you, Dominique. Thank you so much.
Yes, and also a special thanks to Suresh for actually asking, pushing for this review from Carsten from the IoT Directorate. So it was a real pleasure to have this this review, and we know it wasn't easy to get it. So thanks a lot also for this, Suresh.
Thank you very much. So Juan Carlos Zúñiga, Sigfox. Quick update on the draft Zúñiga LP1 SHIC over Sigfox, co-authored with Carlos and Laurent. So based on the latest version of SHIC, draft 18, and there's now one of the big changes is the reference to the recently published radio specifications of Sigfox. There's also improved architectural definitions, taking into account the decomposition of the compression, decompression, and fragmentation reassembly functions. A little bit further clarification on the text. We're working on optimizing the values for the fragmentation modes, and some clarifications and operation details on other fragmentations are still on the works. So again, well, the big change is that long discussion about having these specifications not available. Now they are, and it's in a public site. So I included the link, but basically it's a link that gives support to developers that want to understand the technology and look at all the details of the radio specification. Now it's available, and it's included in the draft. So then we can easily map the sizes, types of frames, and so on to the data sizes and payloads that we define in SHIC and understand better how to make it work. So I guess on the interest of time, one slide that I don't have is we would like to call for adoption probably of the technology documents. This is the time to do it. So far we have Sigfox, NB-IoT, and LoRa. Of course they are in the works, but seems like the intention of the group is to continue working on these three. So
it is, and at the end of this meeting, we'll be talking about the rechartering and well, the discussion on those documents was already presented to the original charter. So I guess we could adopt that in those documents as part of the original charter, but ideally that would be done with the rechartering. Mm-hmm. And also ideally, those documents would inherit from the data model document and be more specific, for this technology, how you adapt the data model. That also is not chartered. So as long as that other document is not chartered, we are kind of on the edge. But yes, I mean, very soon we wish to adopt.
Okay.
So I'm really also very happy to see that there was the specification that was published. So that's really really good. And did you put all, because I skimmed through it, and there were some some details about different payload sizes and so forth. So this is right now also in the Sigfox document draft.
Yeah,
that
yeah.
you have.
I changed the reference. I made the public reference and a link to the specification.
Okay, so
Just a quick question on what is the meaning of now?
Patrick, your name, please.
Patrick Vetterval, Cisco. What is the meaning of now public? Because if you read the specs is available, but the IPR still belongs to Sigfox, so we can't use it.
Sorry, could you repeat the question?
The thing is that if you read the radio specification that is now public, there is a disclaimer that said that the IPR still apply. So we can't do anything with the spec because the IPR is not open.
Well,
we can read the spec.
It's public.
That's the only thing that we can do.
And if you do read it, it says it's a royalty-free license upon certain conditions. I don't think that this is a forum to discuss this. But,
no, it's just to explain the now public. I think it's...
Well, it's public, yes, because anyone can download them, and that before it wasn't the case.
Yeah. Okay.
So the details are now available, and I invite you to download them and ask technical questions if you have any. Yeah.
So just to answer your question about the call for adoption, I guess we have this discussion about the recharter at the end. So we'll probably do all the calls at that time at the end of the meeting for Sigfox, for LoRa, for NB-IoT. Let's just keep the call for adoption to the end of the meeting.
Yeah, for the three probably.
For the three of them, yeah. So we don't do these 3 times.
Yeah. Okay.
Yeah, sure. And probably that's also a question to Suresh. Suresh, do you think that we need to wait for the rechartering to be done, or can we do today to ask the people the call for adoption? I'm not sure if we need to press somewhere. Yeah. Yeah, at the end of the meeting, we'll do it at the end of the meeting. Okay.
So relaying for Suresh from the Jabber. Yes, please leave IPR out. The IPR owner will need to file disclosure as needed. And for the last questions, go for it.
Okay, so we go for call for adoption. That's
my understanding of Suresh message indeed.
Okay. Maybe we do. Okay. So that so at the end we'll call for adoption for the three drafts that will be presented: first, second, third, and the data model. Okay, that's perfect.
And with this, we welcome Ivalio. Ivo, you've got the.
Okay, hello everyone. My name is Ivalio Petrov, and I will be presenting to you the advancement of the draft Shikova LoRa 1. So the structure of the presentation is what happened since the last IETF and the advancement of the new version and what is coming in the next version. So since the last version, we had a review from Soichi, which was giving some details that we need to specify and some additional information. So thanks, Soichi. And this led to the publication of version number 3. And we also got a lot of new ideas and text from other people from the LoRa Alliance, namely Olivier Jimenez and Marc Lou Guarriarec. I'm sorry if I'm not pronouncing it correctly. And all those new texts will be participating in the next version to come, namely version 4. So what changed in version 3 is improved terminology and adding of security consideration. Then we cleared some of the still pending to be defined parts, and that were related to WAR1 and the selection of RUID size, detect size, timers, and some other parts of the profiles. For the next version, we improved even further the definitions in LoRaWAN. I hope that the new version will be published soon, but it might take like a couple of weeks more. So another thing that is happening in the new version is the addition of a con error for uplink, and it seems that it's much better for those scenarios, according to us. So we are going to go ahead with this, and then we decided for interoperability purposes to try to dedicate an F port for the devices that support SHIC, both for uplinks and downlinks, so that at least some minimum common configuration can be shared for all devices that support SHIC. And another part is for some of the devices that need a little bit bigger headers to be transferring part of the headers in the F port, so as to save, for example, 1 byte. This is the goal of this change. And so part of the interest of the work is also to see how to support the LMS. Of course, QAP support is also primary focus of this work. Another thing is right now we are mandating the window size for downlinks to be always 1, but while it makes perfect sense for devices that are class A, for devices that are class B or C, it might not make that much sense. So this is something we are revising. And then there were some questions how we go out of some bad state. Basically, if the network is down for a couple of days, which is mostly a theoretical question, but could happen. So after some discussions with the SHIC authors, we got responses that were satisfactory. So that will be maybe just noted in the draft. And yeah, I would like to ask a question. Are there people in the room that have some experience running SHIC over LoRaWAN to share approximately how many RUIDs and how many different, well, if we assume that the RUIDs will be put in the F port, how much of that we need? The idea is to be able to better size the RUID. For now, we have some information, but maybe that will not cover all the use cases. So any input about that will be greatly appreciated. I mean, either now or afterwards, you can directly email us. Okay, doesn't seem that there are people having a saying on this right now. Okay. So what is remaining is definition of IID and checking again that there is nothing remaining to be defined and that all the parameters of the SHIC draft are still covered in the new version of the draft. And with that, we would like to ask you before it's published, at least, to please review the draft, give us any comments. And yeah, as we said, the call for adoption will be a little bit later.
Okay, so we, like I said, Juan Carlos will be doing all those calls for adoption in the end with this charter discussion. You had one good point about the number of F ports, but isn't something that maybe people from the LoRa side, the LoRa Alliance, your co-authors, could help answer?
So yeah, in parallel, there is this question going on there as well. So probably they will also retrieve some answers. I mean, the idea is in the end to be able to cover as many cases as possible. So
because there are many applications which are not SHIC, but if we can talk to those application builders, we could ask them, oh, if you were to migrate to CoAP, I mean, how do you see that would happen, right? They know their application, maybe they can have an answer for us.
Yeah, sure. The goal of my question was just the more input, the better.
Thank you, Ivo. And with this, we'll call Anna.
Hello, I am Anna Minabro. I work with Edgar Ramos from Ericsson to create this new version of the draft. We completely review all the draft. We define the use case we need to apply SHIC on. And we also add how role ID will work in each use case. All the 3GPP explanation of the architecture and so forth is now in the appendix because we believe it's not part of what we need. And we start defining the fragmentation modes for each use case. So the first use case is IP-based data transmission in the user plane. So this is really how to transfer IP packets over the 3GPP network. So as we have already in the past done with ROC, this is already defined for ROC in the PDCP layer in the 3G network, where the RRC and the RLC can choose the best channel to send the compression. So here we have all the information about the IP packet, and we can make compression between the device and the node B. For this kind of transmission, we think that we don't really need fragmentation because the RLC layer makes segmentation and reassembly. But there is an RLC mode of transmission that's called transparent mode, where there is no segmentation, and perhaps there we can use no ACK fragmentation. But this is also, we will need to see how it really works in the 3G network. For the rule ID in this kind of use case, there is no problem because here we have a PDU of 1,300 bytes, so there is not really a problem about which size of rule ID we need. The next use case we put it is how to send the IP packet in the control plane. And here I don't really have the management of the 3G network. I'm in the control plane, so it's like I'm sending an SMS message. So I have between 11 and 25 bytes. We can use a rule ID of 2 bits. We need fragmentation, and we can make this SHIC compression fragmentation between the user equipment and the router. SGSN is a router. So We can also send IP and non-IP data. They call non-IP data the COAP message for management in the network. So COAP message has no an IP header. There are only COAP. So we can use SHIC for COAP only, and we can also use SHIC for IP UDP packets, data packets. And the third use case we define is how to use SHIC beyond this network as a tunnel. So I make the compression and fragmentation in the device, and I transfer these packets until the end, the application server. So then the 3GPP network is blind. I only transfer the data, and I use the SCF router that makes an IP tunneling between the device and the application server. And here, of course, the question is about fragmentation. We are not sure we really need it because it's a tunnel. So with the bandwidth is not so small, so we need to see that. For rule ID size, again, we don't have any problem about which, if we use 1 byte, 2 bytes, it doesn't care. So that's what we have defined in this version. And again, we want to know if we accept the document for working group. Okay.
So yeah, you know the answer.
Questions?
Any question? Well, thank you so much, Hannah. We will move to the next presentation, which happens to be somebody I know.
Hello.
So Laurent Toutain.
Thank you. So I'm going to talk about the data model. So it's something we started to work at the beginning of the SHIC group, but in fact we focus more on the compression and fragmentation. So now it's time to go back to that. In fact, when you read the document about compression, when we describe the rule, it's in a very abstract way. We didn't try to put JSON or things like this to influence the implementer. We just wanted to define what we have in the rule. And now it's time to have something that is more formal to cover what we will have in all the documents that the group produce. So it's compression of IP, UDP, and COAP, and also other groups that may use SHIC and standard or non-standard. So we have to add maybe new field ID, new matching operator, or new CDA. So we have to see to have a very flexible model for that, and of course that guarantees the interoperability when we exchange rules. So here it's an attempt to do this by using COAP, Young, sorry, and CoreConf. Sorry, I didn't write it correctly, so I have to learn more about CoreConf. And what is important when we define this model is that in fact we will use CoreConf, we will use CBOR, so to see how we can have the most compact representation of the information, because maybe it can go to constraint link, or we have to store a lot of rules. So if we go back to the rule as it is defined right now, so it's just a table, an ASCII table, that say that we have rule IDs, and for each rule ID, we have a list of entries. This entry contained a field ID. So a field ID is a unique value that is used to do the matching between the rule and a parser that will analyze the packet. So the field ID has to be unique. In some implementation, like OpenSHIC, we have, for example, IPv6.version that say that it's the version field for IPv6. Of course, it's quite long value, so we have to find a way to reduce it. After that, we have a length, and the length can be the size of the field in bits, or it can be also a function. For example, we define variable that says that we don't know when we create the rule what will be the size of this field, and so we have to send the value on the residue to be sure that the receiver will understand the same size. So we can have some function and some number. Field position FP is just an integer because, for example, in CoAP, you can repeat several times the same field. So we say the first time is a 1, and if it's repeated second, etc., etc. We have the direction, that is up, down, or bidirectional. We have a target value. So a target value can be a number or a bitmap, can be a string, or can be also, because we have the matching operator, match mapping operator, and it can be also an array of values. An array of values. So we have these different kind of things, and then we have the matching operator and the compression decompression action that are functions. Currently in the standard, the matching operator can take an argument. For example, MSB, most significant bit, can take an argument that says the size of the bit. And CDA currently has no argument, but maybe in the future we can have CDA with arguments. So we have to put that in a model. And something also that is important is that the rule ID is composed of a value and a length. So in theory, when we are sending things with SHIC, a most common rule can have a shorter representation than less common rules. So we have all these things, and of course, fragmentation and compression are in the same space. So it's what we define in the standard. So now we can represent it in Young. So here we have the Young tree. So here it's for a device. So we have the SHIC context. The SHIC context is defined by a list of rules. Each rule is defined by the rule ID and a rule ID length. But if, for example, you align your rule ID on the left side, then rule ID can be an index to find the rule in when you are looking for it. When you have the rule ID defined, then you have two kinds of rules, the rule for fragmentation and the rule for compression. So here in this model, I didn't put any value for fragmentation because the exercise was more on compression. But for example, in OpenSHIC, we have already defined some value and we can store them in this model. And for compression, so here again, we are going to define a list of fields on tree, and each field on tree will contain all the value I explained before. The only difference is, for example, for the target value. In fact, the target value, since it can be a matching list, then we can have several entries, and this entry will be indexed by their position. So this gives, so here you have the Young model, or Nathan for the Young model. So if now we want to represent it using, for core conf and using seed values, you run Pyong, for example, and you have all the URL here, and you have a number, a fixed number that is assigned to this value. So here I took a large number, but not large enough. If I saw in core conf, it will be in core just before, it will be a larger number that will be assigned. But here we have all the value, all the entries that are here in the alphabetical order. So if we have a graphical representation of this, this is a way we can represent the rule. So for example, rule ID value will be 80,058, etc., etc. And so each field will have its specific seed number. And in the first attempt, what we have to do when we want to describe a rule is just to put for all these fields a value. For example, if I want to put IPv6 header length, so in a first approach, we can put IPv6 header length here, but it will not be very efficient. Then we put the length, 8, we put the position, 1, we say that the rule is up, and then we have 3 possibilities, 0 for if it's 1, 1 if it's 64, and 2 if it's 255. Then we put the matching operator, no argument, the CDA, and no argument. So now what we want to do now is to have a better a more compact representation of the blue information, so what we will put in a rule. So one possibility, and of course, it has to be unique and understood by everyone. So one possibility is to use seed to put in these blue fields. So here it doesn't represent a column, but it represents a value you put in an entry. So for example, if we want to represent field ID, we can have a basic type that is field ID seed type, and then we derive all the fields we know, all the field names we know, into new identity. And when we run Pyong, then we will assign this way a seed ID, a different seed ID, a unique seed ID to all these identities. So it can be done, here I did it for IPv6, UDP, and CoAP. So it's a good way to represent the information, but the problem is that if you do that, maybe seed ID will be very large, and we may have to find some way to optimize what we will put in a value. For example, here, it can be 4 bytes for a seed ID. If we can have only 1 byte, it will be better because we are in a constrained environment. So how we can do that? One possibility, I don't know if it works now because a lot of things may change in the core conf, is that we can also have a shortcut that will be an enumeration of all these fields. And manually, the group will select which fields we want for a shortcut. For example, IPv6 version is not very useful because nobody will modify the version of IPv6. So here we don't need something very specific for management. But for other fields, we can use it. If we use CBOR, value between 0 and 23 are in 1 byte. So here what we can do, for example, is to use positive number for IPv6 and UDP and negative number for CoAP. And here we have a lot of room that remains for new shortcuts. If we do that, so we have to use union to represent this, and we say that the field ID type is an union between identity ref, so a seed value, and a number, a small number that we will have. Currently, union is very trivial because when you send an integer, you send an integer. When you want to send an identity ref, you send a tag and an integer, and you can make the difference between them. So it means that there is no extra cost to send shortcuts. So that's something quite efficient, and I have heard that maybe some people want to add a seed in front of this, and if we have a seed in front of this, there is no more interest because the seed will be long. So we will have to find another way to cut them.
Sorry, Chair had off, and as one of the people working on the SID in the core conf, just an interactive question. Where did you hear that we want to add a SID in front of that?
In the core meeting.
Oh, but that was like only for enums and a very specific case. So it's I think you're safe here.
Okay.
Just so
if we are safe, that's good. Yeah. So we can do that for field ID. We can do this for field length also. It means that of course, when we send a number, it's a positive number, and we create some seed value for function like variable or token length, the two that are defined currently in the draft. And we can have also shortcut, and to avoid confusion, shortcut can be here just negative number. And we have very few shortcuts right now, so we have a lot of room for that. For target value, we have 2 types. So here maybe we have to work more on the way we do that, but here it can be a union between int64, it's the largest field we are using right now, and string that we can send. And as I said before, target value is not enough. We need a position because it's used in the matching list. So we create a group with a target value and this position. When you have only, for example, equal, then you will have the position, but you have only one entry in this group. So it means that if we do that, we will have this coding, and instead of having identity. Here we put the seed, we put length. Here we use, instead of using direction and put up or down, we put a number that we assign to it, etc., etc. Matching operator has a specific value is 4, and CDA has also a specific value.
So Laurent, please, sorry for the interrupt. When you say we put a number we assign for it, that's the short value you were talking about.
Yeah,
right?
that's a shortcut.
Just let's use the same terms because.
Yeah. So the group will have to decide which things that can be. Okay, so this was shorter than I expected, but in fact, this is the first attempt to make a Young model on this. Of course, you can criticize it without problem. I'm not a Young expert, so it's my first attempt to do something on Young. So we have to check the validity, see if it's correct or not. And what is important here is that we will mainly use it on conf, and so see the impact of the choice on the coding of the information.
Thank you very much, Laurent. Is there any question in the room about this data model? Did you get a chance to talk to young people during this IETF? Not yet. So okay, that's great. So we'll ask the same question as for the other documents at the end of this meeting. We'll ask for the advice on adoption.
Okay.
Yeah, so.
Actually, because we have 1 minute more maybe left until, so who is the next presenter? So Carlos. So Carlos, you can. So chair hat off. Just to say what's really interesting when this thing is modeled with Yang is that we have the protocols that go around it. So once you have the data model, you have the data model for actually specifying this, then you can go and configure it, you know, from a server side over the radio, and all this comes out of the box. So that's really interesting. Thanks, Laurent, for doing this.
Carlos, you get the pointer here. Initially, I was really asking the question to Laurent, do we really need to make that very concise? Isn't this between some provisioning system like the AAA server and the network side? So between those two, we have a lot of bandwidth. Do we really care to make that concise? And then getting more and more feedback that actually the devices could provide their own model as they connect to the network instead of producing the URL of where the model is. And if that sort of thing happens, then yes, it's a very good idea to make it very concise. So now I agree. Carlos, the ball is yours.
Okay, thank you. Hello, everyone. My name is Carlos Gomez, and I'm going to present the new draft entitled RTO Considerations in LP1. So as the motivation for this new draft, as we know well in this working group, there are some very important LP1 technologies, such as LoRaWAN and Sigfox, which offer some characteristics, such as reduced bit rates and message rates in some cases, for example, below 1 kilobit per second or below 1 message per minute in some scenarios. And then as a result, we may get long or very long round trip times. In ideal scenarios, the RTT may be already in the order of several seconds or tens of seconds. And in addition, there may be some phenomena that may increase even more the round trip time up to several minutes or even hours in some cases. So the round trip time and also its variance, the round trip time in LP1 is much greater than the typical one that we have on the internet. And for example, the default RTO in TCP used to be 3 seconds. It was a few years ago reduced to 1 second. Also, the default RTO in CoAP is randomly chosen between 2 and 3 seconds. And however, in LP1, we have retransmission timers. For example, when we use CoAP and if we send a CON message, there will be a retransmission timer. Also, if we use SHIC fragmentation, there's an RTO also in ACK-always and ACK-on-error modes. So a question that arises here that we need to face at some point is, okay, how do we deal with these special characteristics of LP1 RTTs? So first of all, we start with some theoretical study. The idea is to find here which is the RTT in what we call an ideal scenario on this slide, it's for LoRaWAN, the next one is for Sigfox. We have some assumptions like, okay, in this ideal scenario, there are no losses, no buffering delay, no processing delay, and we assume some size for the downlink, which is a 4-byte payload, could correspond to a SHIC compressed IPv6 UDP CoAP message. And then the idea here is to try to see which is the range of RTT values that we can get under these conditions, considering that the uplink payload size may be small, such as 4 bytes, or it could be the maximum one allowed by the technology, the layer 2 technology, and also the response, the downlink response, in this case in LoRaWAN, can be in the first receive window or the second one. So the results are shown on this table on the slide. And you can see that, well, there are different colors. The main results are the two rightmost columns. I'm not sure if it's really visible here. You can see it on the document. And the point is that in some cases, for example, data rate 0 and 1 here, the default CoAP RTO, as a reference, is always below the RTT. And also in some of the scenarios, the default CoAP RTO is in quite a number of cases below also the RTT. So we have a similar analysis in considering in this case Sigfox.
Carlos?
Yes.
Just a short question, Chair Hadoff. So this is on a simulation, or did you run it on a real platform? And
this is a theoretical calculation.
this is theoretical.
Based on minimum and maximum, like best case, worst case, under these assumed conditions. Yeah. You have a question.
Yes, Laurent. And your messages are empty, so you don't have the time to transmit a message. Or what is the hypothesis for your request in CoAP? Or?
Well, I looked at, well, for the request, well, you mean for the uplink message?
Yes.
Well, I assume 4 bytes as a minimum, like a low payload size. I'm not totally sure it really matches a realistic use case. However, it's like theoretical, like trying to find which is the minimum RTT we could get, like in a very small payload size in that case.
Okay, because sending 50 bytes in spreading factor 12 is 2 seconds, so it adds a loss.
Yeah. Thank you. So we have a similar analysis for Sigfox, and in this case, we have the same assumptions. What changes is that the downlink response may come at the beginning of the downlink receive window, or at the very end, trying to find again the minimum and maximum possible RTT values. And we find that in this case, the default CoAP is always below the round trip time. So in addition to what we have, we can also find another couple of problems, which is that in some scenarios, we find what we call higher order RTTs. There can be 2 reasons for this. The first one is compliance with spectrum access regulations, which are in force in some regions of the world. For example, in the EU, if a device wants to transmit and wants to use some in some frequency bands, there may be 2 approaches. You may use listen before talk, but if you don't do that, then there are duty cycle constraints that are in force, such as, for example, the duty cycle needs to be below 1% in some specific frequency bands. So there are LPWAN devices that, in order to comply with this rule, send some uplink message which may take X seconds and then stay silent for the subsequent 99X seconds. So as a result, the round trip time here may grow by up to 2 orders of magnitude. For example, it could be like 282 seconds in the worst case for LoRaWAN, 253 in the worst case for Sigfox. And so that's one thing. And there's yet another reason why we may get very high RTTs. For example, this problem is well described in a document by Anna and Lohan, which is the timescale option for CoAP, which is the problem that in some cases, downlink response may be buffered for a long time at the gateway. This may happen if the gateway misses the opportunity for downlink transmission. And in fact, in Sigfox and also in LoRaWAN Class A, for example, a downlink message can only be sent after a previous uplink message. And however, the gateway in some cases might miss the opportunity for the downlink. For example, in some cases, the gateway itself stays silent for a while, complying with the duty cycle regulations, or in some cases, it might be just busy sending downlink messages for other devices. And in fact, the downlink in LP1 is quite a bottleneck. So as a result, the next downlink transmission opportunity might arrive for the gateway only after the next uplink transmission. And when will that happen? Well, it will depend on the application, on the behavior of the device, and perhaps the time until the next uplink message, which will allow the downlink opportunity, may come after a few minutes, even hours. Okay, so we've seen these special characteristics of the round trip time in LP1, and now we could think, okay, what should we do? There are probably two scenarios here, and one is maybe if delay is not really relevant for the application, perhaps we just need to set the RTO or the default RTO to the highest expected round trip time, to a safe value, and that's it. And doing this, we avoid spurious timeouts. However, if delay is really relevant and we expect these higher order round trip times, then perhaps we might need to consider some different approach. So in this section of the draft, we propose a simple dual RTO algorithm. This is basically that the device would be using two RTO algorithms, and one is the high RTO, which is compatible with high RTTs, and the other one is the low RTO, which is intended to be compatible with the lower ones. And in this simple algorithm, the idea is that at the beginning, the device starts with the high RTO, and if we get a number of consecutive samples which are low RTT values, then we go to the other state and we use the low RTO algorithm. If at some point we detect that we are in some interval in which we have high RTTs again, the idea is we can go back to the high RTO state. So the idea here is trying to separate these two different scenarios in terms of the RTT values. Because if, for example, you assume that you try to handle all of this with a single RTO algorithm, imagine, for example, the TCP RTO algorithm, the variance may be so high that it may be very difficult to converge to low RTO values, which might prevent doing quick retries. Okay? Quick in terms of the scales we are handling here, but perhaps it makes sense for the application to get a retry in seconds rather than in hours in some applications. Okay? And for example, also you might consider a constant RTO. And the point is, in that case, you really would need to have two different values for that, two different constant RTOs. Because if you try to use a single one, it will only be adapted to perhaps the low or the high, but you cannot be well adapted to both situations here. So some possible next steps for this document would be analyzing also what happens for what we could call downlink RTTs, which would be initiated in the downlink, and then there would be an uplink response. And of course, studying better, refining the dual RTO algorithm that's proposed here, perhaps evaluating the performance. And the main question here would be, okay, is there interest in this work? And subsequent question, if the answer is yes, then would be, okay, in this document, there are like different kinds of contributions. For example, we have some kind of guidance material for how to set the RTO, which is rather informational. Also, we have the proposal of an algorithm, which is of a different nature. So there's the question of whether it's better to keep this within a single document or perhaps some other approach. So yeah, that's everything from my side.
Juan Carlos Zúñiga. Thanks for the presentation. Well, two questions. First one, I noticed that the draft is not under any specific working group. So are you planning to expand the scope to other technologies. And the reason I'm asking this is because I believe, and we will hear from Charlie later on, the update from IEEE 802.15, but for instance, there could be applications of SHIC to other technologies that are not LP1 necessarily, so maybe multi-hop, in which case this delay could be even more variable or unknown. If that is the case, was that your intention, or are you trying to limit it to LP1 only?
Yeah, so actually the focus of the document would be LP1, meaning the technologies that are, for example, currently the target ones in this working group. I was honestly a bit having some doubts about whether perhaps maybe LP1 could be like the home for this work, but also because this relates a little bit with transport area. That's the reason why this is like not explicitly indicated in the document, but actually I only requested to present this here in LP1, and I understand that LP1 is like the main home for this work, or let's say that potential interest should be in this working group. I understand.
Okay, so just to consider that maybe other technologies could start using SHIC and therefore go up over SHIC, and therefore this could apply.
Yeah, so
well, really, it's related to the work here because we introduced a very weird form of latency. But yes, we are not the only consumers, and certainly this is a transport. This is something which, for instance, TCP does do. The TCP algorithms that are documented are completely not applicable here. But I think it's very important data, useful data for your own document to provide like default values or suggest ways of tuning the RTT for co-op. I think that should be part of your documents because it's an important information.
Okay, the job scribe for Mina Ruddy. Similar questions, by the way. Does this draft propose that the retransmission timeout values would be set in the protocol of the respective LP1 technologies, or to be open to be configurable by the application/network manager?
well, the idea is that basically this offers in the analysis part of the document. Michael, sorry. Kind of falling. Okay. So in the analysis part of the document, basically we study the performance of round trip time for different technologies. So the idea would be for each technology, perhaps we want different settings, and also we may have, like, for example, some RTO algorithm running at the application layer, some other RTO at lower layers like SHIC fragmentation, for example, and those don't need to necessarily be the same, although perhaps it could be interesting to study if maybe the same algorithm can be reused across layers in a way.
Okay, thank you for Mina.
Thank you.
So about the question that you asked about the interest, I think that one of the first observation is that you have some figures that show that timers for co-op are timing out, are overrun. So that's by itself, it's something pretty interesting, and it serves as a support for some other drafts that were proposed here in the working group. So personally, I find this work interesting. Then I would like also to talk to our AD, and we need to discuss what would be the future of this draft. We currently in the proposed charter modification, we'll talk about this. We don't have anything in that aspect, but what I feel is that if you have enough interest and enough feedback, then okay. So Suresh is on the mic and is going on the mic, and he will give us some more information about this. Yes, Suresh?
Yeah. So I think, like, this is like quite a bit outside what we discussed earlier for a recharter. So I'll just like wait.
Suresh, you're breaking up. Can you speak very slowly because you're really breaking up? That's slow. We can't hear you, Suresh. Maybe if you can type on the Jabber.
Yes. So okay.
So, Suresh with a French accent. This draft is quite outside of what we discussed during the recharter.
Yes. That was yes, Suresh. Thank you for underlining this. I didn't want to leave this impression. So it is yes. So hold off until the recharter. Yes, this is definitely what we are doing. What I'm saying is, keep the work and we'll see in the future. And if but I feel that this is a very interesting work.
But there is no obvious response to your question, so we'll see you.
Okay, thank you.
And Suresh, you still appear as speaking on the Meetico? Okay. And with this, we invite Laurent again.
Okay, so it will be a very short update on co-op because co-op compression, because the document has not changed since the last meeting. So we are waiting for a review now about this document. What is important is that we believe that it's a very important document because when you see the feedback we got from the hackathon or the feedback from the review from the main SHIC document, for example, the variable field in field length is not well understood, and there is no example right now in the IP UDP compression. These examples are in the co-op document, and so it's not clear to understand it. So Dominique suggests to move one example into the main document, and this co-op document will explain in more details all the behavior for the field. So that's what we have. So now we are waiting for more comment, and if we do a working group, let's call.
I love the idea of having examples in the appendix. I think that it's as good to put the example in this one document because the other one is flying. It's already shipped. And since the example really relies to what you're doing here, why not put it here? I see Dominique has a strong advice on that.
Not strong. This is Dominique Bartel. The thing is, as I mentioned, and I've mentioned that a couple of times already, the other draft has 3 deliverables in it: the generic SHIC compression engine, the fragmentation protocol, and the application of compression to UDP and IPv6. And in the description of the generic engine, we try to mention the fact that we can compress variable and fields, but we don't have an example. And so people have a hard time figuring how this variable and field are processed. And so the appendix of that, the appendix I'm talking about would not be about UDP and IPv6 compression. It would be how a variable and field could be compressed by the generic engine. And as an example, we could use co-op.
Yes, but
the fact that UDP IPv6 is in the title doesn't mean we can't have an example on co-op.
Right, but some people are just interested in IPv6 UDP. Why bother? They will be interested in this example because they are doing co-op, and so why not put it in the co-op document?
But some people are just interested in the generic engine, and without the example, or we could have a pointer to the co-op draft as well.
Yes, maybe you can.
But then, if we have a pointer, then we have this issue of references and all that stuff. Or we can
you
pretend
put an informational reference in the main spec saying you have an example of that in the co-op spec. But now, if things change in the co-op spec, it's good that the example is in the co-op spec because otherwise you may only delay the SHIC doc, and it's complex enough. Don't add anything that needs to be reviewed.
Okay, it's an example. It's the appendix.
Still.
And we're going to spin new versions of the draft anyway because of the ISG review. So, right now there's how is that called? Respin required or something. The state of the draft. Yes. So, anyway, we can discuss that offline.
Okay. I'm not convinced that you want to change SHIC, but I'm happy.
We've been saying that for a couple of years, and sometimes I think we should have changed things earlier. Like splitting the draft in 3 would have made shipping much easier. But that's my personal opinion, sorry.
Okay, well, then we now I have a question for Suresh again, if he's hearing us. What we seem to need now would be help from probably core and reviews from people who are more expert on the co-op side. Would there be a way through the IoT Directorate or directly through the Directorate to get some early reviews from people who are experts in core? That would really help. And then if we have like a core expert reviewing this, then I'm totally happy to start the workgroup last call.
And probably that there will be a second question on that, and this would be like we see in some of the drafts of the technology draft, we see that there is interest for running co-op over SHIC. We already know that it works. Now the question is generally, okay, do we want to push it further? So that's also a question that could be open to you, to the working group, is do we want to delay further the document and try to make it like very, very, very optimal? Or do we say, okay, we are ready to ship this version, it's working, it's pretty good, we don't even know if it can be done better, right? So do we say, okay, it's enough as it is, we ship today, and in any case, we'll need to have feedback from terrain deployment, and that is not going to happen in a month. So that's going to happen in 1 year. Do we have V1 today and V2 in a year, right? So I'd like to hear actually a hum on this, because we'll be standing on this document, on this draft for quite some time now. So can I just have a raise of hands? Who in the room has read any version of this draft? Okay, around 10 people maybe, if I'm not mistaken. So out of these people, who would consider that we should keep with this simplification, let's say, so go with a version today, and if in 1 year or a year and a half we decide that, well, there are sufficient use cases to do something better, then we go with the next version. So if you are for this option, please raise your hand. Okay, so everyone that has read it, I think, has voted for this one. So who would say that we delay the draft until we have some potential, like some more data, and maybe we delay the draft for 1 more year, for eventually get maybe something better? So please, yes, please raise your hand now. So nobody's raising their hand. So for me, that would read that we could do a working group last call, and okay. So yeah. Please.
So Suresh, with its AD off, please ship it. Even repeat it twice. So
I think and he put also with hat on. Yeah. So okay. So we have from our AD we have please ship it. So that means that we'll be doing a working group last call, and we will copy core on this. And yeah, we have to review by core. So this means that here it goes. We're on the way. So thanks Suresh for this, and thanks everyone.
And with this, we're going to move to the next presentation, which is OAM by Dominique, which is something new in the future charter, if it's to be adopted.
Okay. So. Okay. Because it's new in the in a new charter, we save that work for the future. Basically, I'm here to report that we haven't done much over the last month on this one. So a little bit of history for those who haven't followed that one. Originally, there were two separate drafts by two different set of authors that were presented and discussed at IETF 100 and 101, which is already a long time ago. And then we decided we would join forces, so we merged everything in one single draft. And as I just said, this work was put aside for the best part of 2018 to finish the IPv6 SHIC draft. Just to remind everybody, there is a general interest in operation, administration, management for IoT networks. And these are typically, I mean, we want to do very simple, basic stuff. We want to have ICMP error messages that users expect from, you know, the IP network. We want to be able to do a ping, able to do a trace route, and see the network respond with the messages we're used to. That's the very basic stuff, and we're still open to other use cases. Do we want to do more functionalities in that direction? The use case discusses whether those messages should actually go over the LP1, or if they should be proxied at the core, and the core should answer on behalf of the devices without actually sending a message over the LP1. So that's also part of that draft. And of course, we're going to use SHIC to compress those messages. So this is a slide from IETF 100, which describes the various scenarios that we're considering right now. So we want to consider a device that sends an IP packet to the internet, and for some reason the message is not delivered. We want the device to get an ICMP error back so it can do something. We want the device to be able to do a ping, just make sure the destination is still there. We want users on the internet or applications on the internet to be able to send an IP packet to the device and get an ICMP error message back in case something goes wrong. We want the typically human user to be able to do a trace route to the address that corresponds to that device. Now we have to decide whether this trace route goes all the way over the LP1 to the device, or if we get an answer on behalf of the device from the LP1 network. And we want, likewise, we want to be able to do a ping and get a response. The one case we clearly ruled out is the device doing a trace route, because we don't think it means anything for a device to do that. And yeah, that's pretty much it. So we've respinned the version just 2 months ago to revive that draft that was expiring. We simplified a little stuff. I don't want to go to the details. And we're going to resume that work, and so expect some discussion on mailing list. If you're interested, please contribute to the discussion. And we want to implement that using OpenSHIC and experiment and see if we like it. Thank you.
Thank you very much, Dominic. Do we have any question? Charlie?
Yeah, I'm Charlie Perkins from FutureWay. So maybe I misunderstood. So you said that the SCHC core will respond to echo requests from the internet? That means the device doesn't do it?
That's a question, so you're welcome to the discussion. As we said, this raises a question: what does it mean? As Carlos explained in his presentation, if the device is a Class A device in LoRaWAN, the next downlink opportunity from the core to the device may be the next time the device decides to send an uplink, which depends on its application. So that might be tomorrow morning. So what does it mean to ping that device? Maybe it's enough for us to say that from the core, the device is provisioned and is reported as being as live as it can be. And so maybe this is what we want back. The device is still there. We think it's still there, but obviously we don't want to, we are not even able to send it a downlink right now. So
maybe it needs a different reply code, like exactly what you said. We think it's there, but we're not checking right now.
That's exactly what those codes. I didn't dive into the details, but we had code 0, code 1, code 2 to adjust the behavior we expect from this. So typically, that's part of the upcoming discussion.
Yes,
Thank you.
That's a good discussion, but if we create a new code, if you have a device on the internet that doesn't know about LP1 and do a ping, and you receive something it doesn't know, then it can be also a problem. So maybe sometime we have to use the same codes.
So then it's a matter of deciding which is worse, to fool the application on the internet into believing something that's not really known, or making sure that the applications on the internet actually have some programming that makes them have sensible understanding of the device.
Yeah, so that's exactly the discussion we want to have is what do we expect from, what's the best behavior we can expect from this kind of...
Yes, maybe LP1 ping is not ping, and maybe the application that you type on your shell is not ping, but it's LP1 ping. But at some point there was an IPv6 ping, right? There's ping -6 or ping -6 or whatever. And same for traceroute. I mean, there used to be different applications for v6. So it might be that you might need an option to be able to ping a device and get sensible result. I mean, I'm not against that. There's no problem with that.
Definitely.
It's a great point, Charlie.
That's a discussion to be had.
Yeah, about this, I remember that Suresh mentioned that he has been working on some way to make the distinction. Like if you have the SHIC thing, so the gateway or something that will answer instead of the device, so we can have a different ICMP code or something. But that is a good question. So maybe we'll need to get some input also from him to see what was the work that he was doing there. But looks like there are two different cases, and that looks really interesting to me personally.
So I'll definitely ping him.
Okay, thank you very much, Dominique. We have 2 presentations left. We have all the time we need, I guess. No problem with that. And they are kind of, I looked at them and they are kind of off charter. We'll have this presentation, but I would like to just take this window of time to do all the call for adoptions before people leave this room, in case some people want to leave early. Just want to make sure that the call for adoptions are done. So please be prepared, it's happening now. And so we'll be raising hands for the dumb questions. So first drafts we'll be talking about will be in the order we presented them, will be Sigfox. So you can please present the slides, but we can start calling as you switch. Okay, so people willing to adopt the Sigfox technology document per our current charter, so the old charter, the new will be good, but it's already present in the old charter. So willing to adopt, please raise hands. Okay, roughly 10. Opposed to adopt? Okay, we'll confirm on the mailing list. So same question for the LoRa document, willing to adopt? Okay, same kind of hands. Opposed? Opposed? No joke. Okay, so we also have on the Jabber. Okay, so it's all positive. And NB-IoT willing to adopt? Opposed? And now the data model, the fantastic new document that Laurent has presented to us. Willing to adopt? Okay, same hands pretty much. Opposed? Okay, so we'll be confirming all this on the mailing list as usual, and we'll keep the authors aware on this. And with this, yes. So in the minutes, please say that for all four, we got pretty much only positive responses, and that was around 10-ish number of hands raised plus the chairs. No.
So that's great. Thank you also to the others. So we'll, as Pascal said, we'll confirm on the mailing list, and once we get the necessary feedback, you will be invited to submit as a working group document. For the rechartering discussion that we had, so let me just switch the slides. We have already discussed this, and basically most of the things are as in the old charter, with some, like the second item, the second charter item was split. So here what you have is in black. That's what we have today in the charter, and we just are making it explicit. And we had a question on the green one and on the orange one eventually. So the green one is about OAM, and one of the questions was, okay, we can really make it pretty specific, or we want ping in this sense or in that sense, so in the sense of the draft of that was presented just beforehand. So that is something that we would like to get some input on. So do we leave it as it is? And that's the first question, and we'll need to get some answer for that from Suresh. And the second point is, do we include? Is there any interest in which is the time now about security or something else?
Yeah, well, the point is probably now that the ball is in Suresh's hand, I guess. We discussed over the previous two meetings, pretty much the charter that you have in front of you. We had those questions about security IPv4 other. There was nothing which really came out of that. So we posted to Suresh a candidate charter which has all four items on this paper. And Suresh, if you have any news for us about, where that request from us is now standing? Anything you want to tell us about that?
Yeah, maybe probably we can.
Goran?
Göran Selander. I just like to...
Goran, please state your name.
I'm Göran Selander. Slowly. Okay, so now I start again. Okay, so I think this the SHIC header compression of co-op had a very good part. I mean, the security for compression for OSCore, which I think was very useful. And there is a accompanying key establishment protocol, a key exchange protocol called ad hoc. And if anyone is interested in that, that's a very compact way of doing a key exchange. So you could do it for pre-shared key-based authentication in 45 bytes or less, 3 messages.
And could you do it without any change, or is there any mechanism that could be missing from what we have in the two documentation?
I'm not sure. I mean, basically...
That would be a great feedback to have now.
Right. I don't have that at hand. Sorry. So this was... we've talked about this offline, and I haven't really had time to look at this. So this is just, since the security question mark was on this slide, I just want to acknowledge, I think it was good work done on compressing OSCore. And if you're interested, there is a key exchange protocol, if anyone is interested.
Fantastic.
Thank you.
Okay. Thank you, Goran. And with this, we move to Charlie, I guess. So that's... Oh, Suresh is back. So maybe Suresh can you try to speak, Suresh?
Can you hear me?
Yes, perfectly, actually. This time it's very good.
Okay, so I just want to understand a little bit more about the IPv4 stuff. Like I was not very supportive of the IPv4 work before. So if somebody has like some real item they want to work on, let them put it forward, because I haven't seen any drafts or any proposals, right? So at this point, my answer is no. But if somebody has like a real use case, let's talk about it.
So I think Anna is coming to the mic. This was evoked maybe 2 IETFs ago, right?
This is Anna Minaburo. Then we get this input from the narrow IoT part in order to have IPv4 compression in the 3GPP network. But I have no more input there.
Okay.
And Edgar is coming as well to the mic.
Thanks, Anna. Edgar, go.
So let's just get Edgar. I'm sorry, Charlie.
Oh, no worries.
So Edgar, we have you.
Yeah, hello. Edgar Ramos. Yeah, I did some kind of survey, try to find out how much interest there was about having IPv4 for narrowband IoT. What I found out is that there is a lot of deployments of operator networks at the moment that are IPv4 only. And then there are also a lot of deployments of, let's say, external networks, which are IPv4, even if internally in the operators they use IPv6. So basically, many devices are still using IPv4. Say that, I don't find very difficult to use the, let's say, the plain SHIC as it is to compress IPv4 on the narrowband IoT case as it is, because I think, I mean, if that kind of support wants to be introduced, it's quite easily introduced by 3GPP. But then if it goes over the top, then it becomes more tricky. Then I think there is where it requires some kind of more general solution. Then I'm not sure what are we actually targeting. If we are targeting like going for legacy as well here, then it would be good to have something in IPv4, but just to handle the legacy. If we are okay with, let's say, waiting to see what happens later, and then IPv6 adoption grows and so on, and then we are targeting that kind of deployments, then I don't have any problem to leave it as it is. It's just the indication of the market, how it is at the moment, and what we see at the moment outside. I think it was something like half of the networks were IPv4, so it's quite a lot.
So your recommendation would be to have a draft on v4 that would be for the 3GPP type of networks?
Yeah, it's difficult to say if that's my recommendation. I would say that is a good thing to do, but then I'm not very sure. Yeah, I know. I'm not very sure if it is the right way to go. But yes, I think, I mean, my personal opinion is that we should address legacy. Yeah, personal opinion.
Okay, so I take it as a yes, very long yes. Okay, so Suresh is in the queue, so let's see what Suresh, can you, Suresh, I give you the mic.
Thanks, Edgar. Okay, thanks for the info. I'll be like really happy if you share the result of the survey. I'm not sure like how they can scale the number of devices using IPv4. Right, so if you can send a note, like that'll be really good. If there's like a real use case and it's simple, we can do it.
So yes, let's continue this discussion about the mailing list. So Edgar, if you could please send us like a summary of your argument, and then we would build on that. And I see that Juan Carlos is coming to the mic.
Juan Carlos, so is Suresh suggesting doing a chic NAT?
No, I'm not. Like that's what I'm worried about, because I want to see, like, so Edgar was like very non-committal, right? And I understand, because what Edgar said is like he was not recommending it, but he heard a survey. Okay, so and that's what like I want to see the survey and see what the results are like, and is there a way for these people to move forward, right? Because I don't want to be like anti V4 or anything like that, but I just don't see how V4 can work like to the scale that we need, right? Like especially with like NB-IoT, where we are trying to scale the number of devices to, right? Like, you know, when the devices become cheaper and with longer life, like we're going to see like a proliferation of the number of devices, and I just don't see V4 cutting it, right? So that's really what I'm worried about.
So Suresh, why don't we recharter with the 4 items, start the work on V4, and if it really seems useful, then we can still recharter a little bit more, right? I mean, it's not like it's the end of the world if we recharter twice.
No, it's not at all, right? That's what I'm saying. So like until we know more, and unless there's a work item, like I don't want to talk about it during recharter, because usually like the stuff we're talking about for a recharter has like some kind of draft that's been around, we discussed it, right? So let somebody write a draft, or like at least write like a problem statement or something like that, right? So what we want to do, and then we go for the recharter after for that item. So it's just a question of adding a milestone somewhere. So we don't probably even have to go for a recharter. Like, you know, I can put you some VSL text that'll let us add a milestone later if you want.
Okay, so about the current charter that we proposed to you, do you have any status for us? The 4 items that we...
Until the OAM, that sounds good, personally for me. So...
Okay. So does it mean that I mean, what's the step to get the charter through? Do you accept it?
No, like I had to go through the process, right? So I need to go through an internal review with the ESG, an external review for us and the other external organizations we talk to. So it's like just a mechanical process I need to run through. Okay, so
right.
Personally I'm okay. So like if I'm okay, like, you know, then I have to do the rest of the process.
Fantastic. Thank you, Suresh.
Okay, relaying from Jabber, from Soti Shan, a little bit outdated and desynchronized, but get feedback from 3GPP on IPv4 usage. It's coming up a little bit late in the conversation.
So if I understood correctly, and Pascal, correct me if okay. So Suresh is on the mic. So this is also a question for Suresh. So we go on without IPv4 for now, and we see if there is work coming up, if there is a draft out, and if there is input from somewhere, then in the future we might do it, but not today.
Yeah, thanks, guys. So if you want, I can send in a liaison statement to 3GPP to get an answer if the working group wants me to check with 3GPP about IPv4. Okay, so I'll work with the chairs and write up a liaison statement and post it on the list and then ship it off.
And if we find interest, we'll submit to you an addendum to the charter, and we'll reach out with it. Okay. Fantastic. Okay. So, Charlie, sorry for keeping you.
No problem.
Suresh, you're still on the mic.
This direction.
You moved the slides.
So this, I originally thought I would come here and discuss some of the things that's going on in the Standing Committee in IETF for 802.15. And so I will do a little bit of that, or a lot of that, relative to the whole presentation, but it's a very short presentation. And then Pascal asked me to give a little review of what's actually other groups in 802.15 are doing. So most of that stuff, I don't have a lot of information about it because I don't go to the other groups. And second of all, I don't think it's very much relevant to IETF. 802.15.4W is the low power wide area group, and that document has made a lot of progress over the last few months and it's now sent out for letter ballot, which you could think of as a little somewhat like working group last call. And so I'm pretty sure it's going to have to go out for a couple of last calls or letter ballots, and presumably sometime in the summer or fall it'll go out to wider audience for to finish the standard. 4X was just approved by the IEEE Standards Association, and that's it's called Field Area Network Extensions, but what it really boils down to is just adding more parameters to some tables for quadrature, phase, shift keying. I'm not too good on those things. 802.15.10a is an amendment to the layer 2 routing document that was approved for standards. It was published early last year. And that could well be of interest in this group, but and to the IETF in general, but it's layer 2 routing and not layer 3 routing, but it goes up, it's highly scalable to thousands of devices. And the content of 10A had to do with something that was under-specified in the original document, how to handle source routing, basically. One of the major topics of discussion has been coexistence between 802.11ah and 802.15.4g, and this is somewhat precipitated by work in 802.15.4z, which is, as best I understand it, a revision of ultra-wideband. And there's a lot of, well, when you get to low power, interference issues can really cause a lot of difficulty. And right now, it looks to me like 802.11ah sort of wins on throughput, but really suffers on latency. And conversely, 802.15.4 can get a little better latency in terms of when there's interference with 11ah. And I don't think this is the only scenario where the coexistence concerns are, but it's really comes up to the fore with low power. And then lastly, I'll mention in 802.15.12, basically the idea or the charter of 802.15.12 is to make 802.15.4 as nicely programmable as 802.15.11. I mean, 802.15 is nicely programmable as 802.11 because 802.11 has a relatively easy to understand interface to layer 3, and that's been a source of a lot of popularity. And the philosophy in 802.15 was that, well, we want to make the devices really small, so we put all the stuff in higher layers, and that's not been very successful in some ways because that means that all the normal stuff you would think of that has to be done on the device for, say, by hop transmissions or whatever, has been done differently in different ways, I mean, different implementations. So now we want to make it more like 802.11. And that work is proceeding at a regular pace, and I think it'll be made available sometime in a year and a half. So that's some of the activities in 802.15, but not all. There's also an 802.15.4y that has to do with adding some security measures to the to 802.15.4. And I have not followed that, but I noticed that Taro's here, and he's one of the authors of that work. So Taro wants to say something about that.
Tero Kivinen. Yeah, it's only mostly going to just add, this 256-bit AS there. We have 128 bits, and then there was some standard organization in different countries saying, oh, it would be nice to have a 256, or at least have a roadmap for that in case we happen to have quantum computers ever. So that's just getting ready for the future if somebody ever needs it.
Okay. Well, actually, okay.
Yeah.
I'm almost out of time. Oops, I better hurry up because I hadn't hardly got started. Sorry about that. Well, this slide I don't have to describe to you, but I just mention that this is actually the presentation I made to the 802.15.4 group. And so I wanted to make, first of all, the point of this is to make a document for 802.15.4, update of the current document, of the document that we had out there. It's not current anymore, but we wanted to show how to use SCHC or SHIC with 802.15.4, and not just specifically for 4W, but for .4 in general. So in order to do that, you have to compare apples to apples. And one problem was, well, what about fragmentation? Do we use SHIC fragmentation or do we use 802.15.4 fragmentation? And in order to figure that out, I tried to make some estimate on the minimum header sizes and with SHIC head fragments. And so, roughly speaking, I think if you're really, really minimal, you can get everything into a byte for the fragment header for SHIC, or even less perhaps, but let's say a byte. And then there's this MIC. And actually, I want to make sure to get this point across. Since 802.15.4 is going to put a frame check sequence on every frame, we don't need the MIC. Now, I was going to try to convince you to make the MIC optional, but according to the previous presentation, it's already been made optional again, so that was great. Thank you. So in order to compare properly the fragmentation from SHIC versus using 802.15.4 fragmentation, I had to go in and do some estimates on what the 802.15.4 overhead is per fragment. And since I'm really short on time, I'll just say that it matters a lot about some assumptions you make on the 802.15.4 headers, and you can get probably about 5 to 7 bytes overhead per fragment, if that, and that depends on what all you think about compressing on the MAC header. So, and I want to also mention as briefly as I can that when I described the SHIC header to the 802.15 or the Standing Committee on IETF, by surprise, I got everybody complaining because I called it MIC, and they said it is not MIC, it is FCS, frame check sequence. And so they recommended that the IETF document change from calling it MIC to calling it FCS. And I don't have time to really go into that right now, but we can talk about it on the mailing list. Okay. Okay, so please go ahead.
Dominic Bartel. So it all depends on what you call a frame. For us, a frame is below SHIC, so our MIC is to verify the integrity of the whole set of fragments that we're sending, and each fragment is encapsulated in a frame. So that's why we don't want it to call it a frame check.
Well, what their argument was that it's not any sort of integrity check because it's so easily defeated if somebody wanted to, forge a little bit of the data. And in other words, you can do it cryptographically, but if you just use the sort of checksum mechanism, it's not good enough.
So it's the word integrity, I guess, which has a strong security aspect in it, which kind of hurts here. Well, let's not have this discussion now, but we can discuss it on the mailing list if we need to rename the MIC.
I don't think it's not an important point to me, but they thought it was important. So I wanted to say it. Okay, so I don't have to talk about this. I'll just say that the way I estimated the minimum MAC header size was to take every one of those numbers, there's a 2 and there's a 0/1. If there's ever a 0, I said, okay, we'll delete that part of the frame. And so all this stuff got deleted, but the security control had to be there. And you'll notice that the frame check sequence is not going to be deleted. It's at least 2 bytes. So that's where I got the MAC header overhead to estimate. Because when SHIC sends down the fragments, the MAC layer thinks every one of those is a frame, and it's going to put the frame header on every one of them. So LECIM is what's been in 802.15.4 for a long time, low energy critical infrastructure monitoring. That was what they thought was going on with low power wide area networking 10 years ago, whatever. So there was a big debate about, well, maybe we should get rid of LECIM and just put low power wide area network in there, but so far that hasn't happened. And the thing about 802.15.4 fragmentation, it's only defined for this LECIM or low power wide area. And in order to do it, you have to incur the overhead of first sending a fragment control information element. And so what I did was amortize that initial fragment control thing over the total number of fragments. And I don't know how many fragments you would get, but if you had just 4 bytes for the SCSD, and if you had 4 fragments, at one byte per fragment.
1 minute, Charlie.
I'm out of time.
Yeah.
Well, okay. Well, that's the way it goes. And so I will spare you this fabulous discussion about frame type values, and I guess, so one thing I have to mention is that in order to compare apples to apples, we really need to know about the security model for SCHC, and what is that? I tried to propose really reducing to the bare minimum the MAC header, and people were upset because there's no security there, and the argument went on. So I guess I have to be done. Let me just one last observation, that the MIC itself is often done on chip for 802.15.4. So this is in addition to the frame check sequence. And if SCHC wanted to do something about security, then we would have a solution here that would be handy for 802.15.4. I guess that's it. Okay.
Thank you very much.
Thank you very much.
Thanks, Charlie. So yes, and very good question. Please, the next presenter, Tobias. Tobias. Thank you very much, Charlie, for this. You put some very interesting questions. Hope to have them answered on the mailing list and to see progress on the draft on the 802.15.4 SCHC over your technology. So, yeah, thanks.
Okay. There you go.
So, hey, I'm Tobias. I would like to briefly talk about ESP header compression. So ESP is IPsec, so IP security. So this is clearly nothing here in LPWAN that's happening in IPsec-ME, but because we're using a lot of technologies or ideas SCHC was developing, Karsten encouraged me to present it here very quickly. So I guess most of you know IP. Not every one of you probably knows IPsec. So what basically happens, IPsec encrypts everything which is in the IP payload or even the IP header itself. This looks basically like that. All the red stuff is encrypted, which means it cannot be compressed between layer 2 and 3, where usually compression is happening. So we could only, for example, SCHC could only compress the ESP header, but everything else couldn't be compressed. And the good thing about IPsec, because you build a security context which includes a lot of these values, compression could be quite efficient, and you have a static context between the two nodes. So everything in green is already there, so we don't even need to build up a context. And everything in blue can be calculated as it's done in SCHC anyway. And the other few things are typically static. So what we do with the ESP header compression, we just use that. So we already have a static security context between the nodes which are talking to each other. We even have a separate channel, which is, as far as I know, what is missing for SCHC at the moment to agree on the compression context. We can use IKE, we can use group IKE for any kind of group communication. We can use HIP, or we can just do it static and compile it on the firmware. This context already holds the values we want anyway. We call it traffic selectors, for example, IP addresses, ports, and whatever. And we have done this before. I think a few of you know ROC and ROC over IPsec. So something similar has been done there before. So what we did at the ESP header compression, we just defined how to do it. And that's probably why Carsten told me to present it, because I guess most of you know this kind of actions and rules. They look very similar to what is defined in SCHC, because they are inspired from ROC and SCHC. We defined them in the document for ESP, so for the ESP header, for IPv6, for IPv4, so this also means IPv4 is not really a big problem for us. We defined them for TCP, for UDP, and for UDP Lite. And this looks like a lot, so I quickly went through it. That's like 59 header fields to exchange rules for. If you cut them to like ports and stuff, then you still have like 44 header fields you need to exchange. But because so much stuff is already there, we defined a strategy which we call Diet ESP, which optimizes this exchange of the context, and which leaves us to just define 9, or to have me to exchange or flash 9 context values, which we can then use to compress all these fields. So we basically have, in an optimal case, we have no overhead of any protocol inside ESP. And we already discussed this a little bit offline with the people who did SCHC, so basically with Dominique and Laurent. I think it could be even easily extended to co-op, because that was also something you couldn't compress otherwise. So that's basically it. I'm happy to take questions offline, and if someone who thinks this is kind of interesting wants to read the draft, yeah, I think you will quite align that to what will be the final document in SCHC, so that the wording is similar once this is done. Okay.
Many thanks, Tobias. Any question in the room?
I have one question, and just before we go, and that is, did you find, because we hear a lot of SCHC used in security context, so did you find the description of the SCHC full enough? Like, do you find some things that you would like in the future to be added eventually, or so that, yeah, something.
What do you mean?
So I mean, you just took the SCHC draft and you applied it and it worked, and you did not need to.
Pretty much, yes.
Yeah.
I mean, I think when we designed it, it was like version 2 of the SCHC draft, but I mean, this kind of rules didn't really change a lot. And yeah, maybe they changed a little bit, but and the security, I mean, then you have the whole security of IPsec gives you. So you have an encrypted payload within IP. That's what you get. That's the security you can get with ESP. End to end.
Perfect. Thank you very much. With that, we're out of our time. So thank you very much. Thank you, everyone. Please don't forget to sign the blue sheets in case you have not done so. And have a nice evening.
Yes. Meeting is adjourned. Thank you so much.
There's...
Does anyone have the blue sheets?